Welcome back to another episode of Math Tutor Takes the SAT. I'm your host, Connor, and today we're going to tackle questions 6 through 12 of the first module of Test 1. You can download the test by visiting the link in the description. All right, let's get started. All right, question number 7. The function f is defined by the equation f of x equals 7x plus 2. What is the value of f of x when x equals 4? All right, so pause the video and see if you can figure this one out. All right, so I covered functions in my last video, question number 4. So if you're confused on what a function is, go ahead and watch the video. I'll link it here. But to just recap briefly, a function takes some input and it gives you some output. So for example, this function right here, the way it's defined, if you give it the number 2 and we're calculating, say, f of 2, then that's going to be, well, you just substitute 2 wherever you see x to figure out what the output of the function is. So f of 2 is 7 times, well, we've got an x here, so 7 times 2 plus 2. And that's going to be, well, 7 times 2 happens first, that's 14 plus 2 is 16. So using our function diagram from last time, if you put a 2 into this function called f, it outputs a 16. But the question is, what is the value of f of x when x equals 4? So we just have to kind of translate this to what we've been doing over here. All this says is, what is f of x when x equals 4? So just replace x with 4. That's all you've got to do. So f of 4 is, well, a definition of our function is 7x plus 2. That's the output. 7 times whatever the input is plus 2. The input we're saying is 4, so replace that with a 4. 7 times 4 is 28, plus 2 is 30. And that is the value of f of x when x equals 4, or that's just the value of f of 4. And so that's our answer, 30. All right, so question number 8 says, a teacher is creating an assignment worth 70 points. The assignment will consist of questions worth 1 point and questions worth 3 points. Which equation represents the situation? Where x represents the number of 1-point questions and y represents the number of 3-point questions. So pause the video and see if you can figure this one out. All right, so it looks like this question is going to ask us to come up with an expression involving x's and y's that's somehow going to calculate the total number of points on an assignment. Because we see a bunch of these expressions involving x and y are equal to 70 in all these answer choices. It's saying that this is somehow, I don't know if this is the right one, but this is somehow the total number of points on the test, and that equals 70, because every assignment is worth 70 points. So let's see if we can come up with the right expression for the total number of points. And if you struggle at these, then one method that I like to do is substitute numbers for x and y. Instead of these little arbitrary variables here, we can just let x be 4, a number that makes sense. Say that there are 4 1-point questions on the test and that y is 6. There are 6 3-point questions on the test. Well, then you could probably calculate the total number of points on that assignment by hand. So let's do that. So the total number of points on that assignment would be, there are 4 1-point questions. X is 4. So you would tally up the number of 1-point questions, and each one is worth 1 point, so you do 1 plus 1 plus 1 plus 1. That's 4 points for those questions. And then there are 6 3-point questions, so you add on to that 6 3-point questions. So 3 plus 3 plus 3 plus 3 plus 3 plus 3. And from these 6 3-point questions, you're going to get 18 points added to your score if you get them all right. When you come up with this initial expression, it's not going to be one of these. You have to figure out how to use x and y in here. And right now it's not that obvious. But what we can do is say, well, we're adding 1 to itself 4 times, right? That happens to be the number of 1-point questions, right? So we can just write 4 times 1. Plus, we're adding up 3 6 times. That's the number. 6 is the number of 3-point questions, right? So we just say 6 times 3. Now you could compute the total number of points here. You could say, okay, the total number of points on this test is 4 plus 6 times 3 is 18, so 22 points total on this assignment. Well, that's not 70 points. We chose the wrong x and y. That's why. But that's not the goal here. The goal here is to get an expression that involves x's and y's. So somehow we've got to go backwards and replace some numbers here with x's and y's. Which ones do we replace, and which variables do we use to replace them? Well, if you remember 4, where did 4 come from? 4 is the number of 1-point questions. So that's probably x, right? So if we put x instead of 4, then that's x times 1. Plus, well, what about y? Y is 6. Where did the 6 come from? It came from y. Y is the number of 3-point questions. We've got 6 3-point questions added together. So 6, this needs to be replaced with y. So y times 3. All right. So we've got an expression for total points involving x's and y's. The total number of points on the test is x times 1 plus y times 3. All right, that's good. And we know that the total number of points is equal to 70. So we could just write this equals 70. X times 1 plus y times 3 equals 70. Because all these have equal to 70, and that's because the assignment is worth 70 points. That's this other piece of information that they're telling us. All right, but if you look at the answer choices, it doesn't look like any of the answer choices immediately. So we've got to manipulate it a little bit to make it look like one of these. Well, you look at x times 1, usually you write the number before the variable when you're multiplying a variable with a number. So let's do that. 1 times x plus 3 times y instead of y times 3. 3 times y equals 70. All right, that looks a little bit more like one of these. It's starting to look like D. Now, if you remember about what it means to multiply by 1, what is 1 times 7? That's just 7. What's 1 times 9? That's just 9. So what is 1 times x? That's just x. It doesn't change the number when you multiply it by 1. So 1 times x, we just replace that with x. X plus 3y equals 70. And that is exactly answer choice D. All right, question number 9 says, right triangles LMN and PQR are similar, where L and M correspond to P and Q respectively. What does respectively means? It means that L corresponds to P and M corresponds to Q. All right, so angle M has a measure of 53 degrees. What is the measure of angle Q? All right, pause the video and see if you can figure this one out. All right, so what does it mean for a couple shapes to be similar? Well, a couple shapes can be similar. I'm going to draw a right triangle to start out with because we're working with right triangles. So I'm going to make this the right angle here. And I'm going to take this shape and I'm going to copy it over here. Now these two shapes, because I just copied this shape over and moved it around, I can even rotate it if I want. So that makes it bigger, sorry. Let's do this again. So I can rotate this shape. And this is congruent. These two shapes are congruent because I can take this shape, I can move it over here, I can rotate it back to where it belongs and move it back. And it exactly matches up. So these two shapes are congruent. But what if I make this one bigger? So I make this bigger, I move it around, rotate it. I could even flip it, take the mirror image of it, flip it over like it's a piece. Now they're just similar. They're not congruent anymore, they're similar because I've scaled this one, I've made this one bigger. All right, but you saw me drag it around and move it around. So you can say that some of these angles match up. These angles aren't gonna change when I move it around and make it bigger. So the angles actually are congruent, they match up, they have the same measure. This angle is just as wide as this angle, and this angle is just as wide as this angle over here. Now we've got to be careful. We've got to look back and actually name these two triangles. One of them has to be LMN and one of them has to be PQR. And we've got to figure out which angles go with which letters. So one of these angles has a measure of about 50 something degrees. It looks like this one I got pretty close to around 53 degrees. So I'm gonna call this one, it says angle M has a measure of 53 degrees. So I'm going to call this angle M. Well, when you're naming triangles, LMN, you could totally name it like this. LMN, where you read it clockwise, or you could also name this triangle NML. If you start at N and go to M and then go to L. There are a bunch of different names for this triangle, but one name for this triangle is LMN. So we got to think, is L okay being the right angle? I don't see why not. I don't see why not. We're going to keep it as the right angle for now, and N will be the other angle. So we've come up with a naming for this triangle, and we'll see if it contradicts anything later when we try to do this other triangle. But if these triangles are similar, triangle LMN is similar to triangle PQR, that means that they have a correspondence between their angles. So I'm going to move this one under this one to show the correspondence. L corresponds with P then, M corresponds with Q, and N corresponds with R. Just like that. And it confirms this in this sentence. L corresponds to P, and M corresponds to Q. All right. That said, we know that L over here corresponds to the right angle over here, P. So this has to be P. M corresponds with Q, so this has to be Q, this angle. And N corresponds with R, so R has to be this angle. And now that we've named both of our triangles, we can take a look back at the problem and see this last sentence. Angle M has a measure of 53 degrees. What is the measure of angle Q? Well, if you know about angle correspondence between similar triangles, and you know that M corresponds with Q like it tells you in the problem, then these angles have to be congruent. Even though this shape is bigger, this angle is just as wide as this angle. So since this is 53 degrees, then this is also 53 degrees. And so the answer is B, 53. All right. So question number 10 says, well, we get two equations, and they're actually together, they're a system of equations. It says the solution to the given system of equations is x comma y. What is the value of x? So pause the video and see if you can solve this problem. So normally what I would do is say, okay, you've got a system of equations, it's linear equations, put them into Desmos, the graphing calculator, and see where they intersect and find the x coordinate, and that's your answer. You can certainly do that. And that's pretty fast. But the algebra, I think, is actually faster if you're good at algebra. So let me show you the algebraic solution first, and then I'll show you the Desmos solution. Okay, so y is equal to negative 3x. It is saying y is negative 3x. We can take negative 3x and plug it in for y in the other equation. We've got to use the info from both of the equations in order to solve this system of equations. Because in order to solve a system of equations, you've got to come up with a pair of an x coordinate and a y coordinate, a value for x and a value of y, that when you plug them into both equations, they solve both equations at the same time. So in order to do that, we've got to use the info from both of the equations. I'm just going to take negative 3x and plug it in for y. So I'm going to take this other equation, 4x plus y equals 15. And where y is, I'm just going to put a pair of parentheses. That's where y was, and just plug in negative 3x because that's what y is. And then what's 4x plus negative 3x? We're combining like terms here. 4x plus negative 3x, or 4x minus 3x is just a single x. And that equals 15. Voila, we've solved the problem. The answer is C. Because it's asking for the value of x. Now, sometimes you might need to know the other value. You might need to know the value for y, because the solution really to the system of equations is an ordered pair. It's an x and a y. But what's the main rule on the SAT when it comes to time? Don't do more work than you've got to do. We found x, and so we're done. Now let's take a look at Desmos and see how we would do that in the nice graphing calculator that they give you Desmos on the SAT now. And so let's see how to use Desmos. All right, so we've got to plug in both of these equations into Desmos. And you may be familiar with, oh, I've got to put it in, if you're working with your TI calculator, you've got to put it in y-intercept form first. You've got to move this negative, or this 4x over to the other side and get y equals, and you don't have to do that in Desmos. You can just plug it in. So take this equation, y equals negative 3x. Y equals negative 3x. All right, we've got that equation. And then 4x plus y equals 15. 4x plus y equals 15. All right. And we are looking for the point where they intersect, if they do intersect at all. All right, and that looks like they're kind of coming to a point down in the graph. So we're gonna have to zoom out maybe and come down here. And we hover over here, and Desmos tells us exactly, we have to click on one of these. We have to click on one of these lines, and then Desmos is gonna have a gray point for us where they intersect. Now, what's the answer? Is it 15 or negative 45? Well, if we go back, they're asking for the value of x. We found it algebraically pretty quickly, but you could just pull 15 straight from the coordinates here. And that's the answer, according to that Desmos as well. All right, so question number 11. Which of the following equations is the most appropriate linear model for the data shown in the scatter plot? All right, pause the video and see if you can figure this one out. All right, linear model. So it's saying, what is the line of best fit? What line goes through all these points almost? And so I'm gonna draw a line that kind of does that. So let's do that. Okay. Start up here, looks like about right here, and just draw the line like that. Okay, cool. All right, so that's good enough for our purposes. We've got to figure out what is the equation of a line that looks like this. Is it this, 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 or this? In order to understand which you choose, you've got to understand what this negative 1.9 means, what this negative 10.1 means. So let's talk about that. So the equation of a line in y-intercept form, these are all in y-intercept form, is y equals m times x plus b. Y is always going to be y, x is always going to be x. But m and b are actually going to be numbers. They are constants. They are fixed numbers. And for example, if we look at, say, c, m, according to c, is 1.9. That is the slope of the line. The y-intercept of the line, according to this equation right here, is negative 10.1. Negative 10.1, because this is the same thing as 1.9x plus negative 10.1, right? That would be mx plus b. This is b. Negative 10.1. All right, that is the y-intercept. That's where it crosses the y-axis, where the line crosses the y-axis. All right, so let's take a look at the slope in a little bit more detail. Let's say that I've got a graph that looks like this. I've got a line that crosses at y equals positive 2 on the y-axis. It crosses there. And then I have a point at 1. It goes up to, let's actually make this 2 down here. Let's give us some breathing room. 3, 4, 5. Let's put it right there. Let's say that this is 5. And then there's a point here at 8. And that's what our line looks like. Okay. So the equation for this line in y-intercept form is y equals 3x plus 2. And let's take a look at what each one of these means. This 2, this is easy. This comes from the y-intercept. This is where this line crosses the y-axis. How does this 3 factor into it, though? The 3 is saying every time you go 1 to the right, this is 1 to the right, you go up how many? I went from 2 to 5, so I'm going 3 up. Every time you go 1 to the right, if you start here and you go 1 to the right, you go 3 up. That's what the slope means. It's a ratio of how far you rise divided by how far you run. Now, this is what happens when we have a positive slope. The 3 here is positive. M is positive here. What happens if we have a negative slope? So if we've got a negative slope, then your line looks something like this. Starts higher and goes lower. As you go to the right, you go down. As you go 1 to the right, you go some amount down. This would be a negative slope. And a 0 slope, you might be able to imagine what that looks like. A zero slope is just a horizontal line. All right, so let's take all of this information and see if we can solve the problem with it. Does this line up here in the diagram, does this line have a positive, a negative, or a zero slope? It has a negative slope. That most closely matches this diagram, doesn't it? All right, so we can rule two of these answer choices out. Which ones? C and D are gone. 1.9, M is a positive slope here. 1.9 is positive here. So C and D are gone. That just leaves A and B. Which one of these is right? Well, if you look at the y-intercept for each of these, the y-intercept here, the number that's not multiplying x, is 10.1, and that's positive 10.1. And the y-intercept here is negative 10.1. Negative 10.1 would mean the line touches the y-axis down here, all the way down here, at negative 10, negative 10.1. And that's obviously not happening. It looks really, really close to 10, doesn't it? So it's probably 10.1. I'm going to say it's positive 10.1 for the y-intercept, and this slope, we don't even really have to calculate it. We've narrowed it down based on the fact that all these slopes it's just positive 1.9 or negative 1.9. And so we see a negative slope here and a positive y-intercept, and we're done. B is the answer. All right, so we've got a graph here in question 12, and it says the graph of y equals f of x is shown, where the function f is defined by, oh gosh, f of x equals ax cubed plus bx squared plus cx plus d. And a, b, c, and d are constants. For how many values of x does f of x equal 0? Pause the video and see if you can figure this one out. All right, so basically we've just got to translate a bunch of math. All right, so let's start out with the definition of functions. We talked about functions in my previous video, question number 4, we talked about functions. And we talked about them as having input and output. And you can actually graph functions, it turns out. Let's say that we're graphing the function g of x equals 2x plus 3. To graph this function, what you would do is for every input to this function that you can think of, you let that be the x-coordinate of some point on this graph, and then calculate its y-coordinate by plugging in x in the right-hand side here. So to find what, let's say you plug in 4 for x, then you would go over here on the x-axis and put 4, and then you would go, well, 2 times 4 plus 3. 2 times 4 is 8, plus 3 is 11. And so we would go all the way up here to 11 and put a point here. Let's see some other points. So let's plug in 2. 2 times 2 would be 4, plus 3 is 7. So we'd go all the way up here to 7 and put a point right here. And if you know anything about this type of function, you know it's going to be a line. So it's just going to be a line through both of these points. And if you see the graph of a function, you can estimate other values for that function. So let's calculate what is g of 4 from this graph. What is g of 4? Well, we could plug it in here, but we already plotted it. We plugged it in and plotted it up here. All we have to do is go 4 on the x-axis, that's our input, and then go up to see what our output is. Our output of our function is 11. So g of 4 is 11. G of 2, we go on our input axis, our x-axis, we go to 2, up to this point here. G of 2 is equal to 7. 7 is the output. All right, so let's use this idea on this graph right here. It gives us this fancy function, f of x equals blah, 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 but you really don't need to know a whole lot about this in order to answer this question yet. You can at least narrow it down. So for how many values of x does f of x equal 0? We want f of, now we're no longer working with our function g over here. We're working with this function f. F of x equals 0. We're looking for what do you put in here in order to get f of x equal to 0. F of x, remember, is the output. X is the input. F of x is the output. So f of x is the y value for any point on this function. So what is, for example, let's evaluate f of 2. What is f of 2? Pause the video and see if you can figure out what f of 2 is. On this graph, if we go over to 2 on the x-axis, we go down to where our line is, or our curve. And that's this point right here. The y-coordinate of this point is -6. So f of 2, the output is -6. What about f of 0? F of 0, we do the same thing. X is 0. We go down to our curve. And it looks like it's about -6. We'll say it's -6. But we're looking for when this function, when you give it a number and the output, f of x, is 0. F of x equals 0 for right here. And it's asking how many values can you plug in here? How many values of x does f of x equal 0? Well, in order to answer this, we've got to figure out where on this graph is which coordinate 0. If you said the y-coordinate, you would be correct. You're looking for where the y-coordinate is 0 because f of x is the output. We're looking for where this is 0. The y-coordinate is 0. So what you can do is you can draw a line, a horizontal line, at ground level, because everywhere on this horizontal line that I've drawn, y is 0. Y is how high we are, how high up or down we are. And so if we're right here, we're at ground level. Where does the graph cross this line? We see 1, 2, 3 points. So it looks like f of -1, f of -1 equals 0. It looks like f of 4 equals 0. And it looks like f of 7 equals 0 as well. And -1, 4, and 7 are called the zeros of this function. They're what you plug into the function and get an output of 0. All right. So you might be tempted to say the answer is 3. And actually, yeah, the answer is 3. Because we've got 1, 2, 3 things that you can plug in for x to make the value of the function 0. But there is a caveat here, and it's that they've graphed a little part of the function. What if this function, the part that they didn't graph, did something like this? It went up and then down, and then there was another 0. How would you be able to prove that there isn't some other part of the function that's not graphed where it crosses the x-axis? If you know anything about polynomials, this is a polynomial, and what's the degree of this polynomial? It's the highest exponent on x, and that's 3. That means that there are a maximum of 3 real zeros. So we know that this function is not going to cross anywhere else. We've seen all of them. We've listed all of them. There are 3 at most, so the answer is 3 and not 4. All right, that's the show. Hey, if you learned something, click that like button and subscribe if you want to see more. See you next time.